Hi students, I am Nimisha and I will be teaching you your next math chapter, statistics. In our lower classes, we have already studied statistics for grouped, ungrouped data. In this particular chapter, so in ungrouped data you have with classes, without classes. So what we've usually done until now is without classes. In this particular chapter, we will be dealing with data that has classes. Why do we need classes? For example, if I am measuring the height of each student in your class, everyone's height will be different, 160.2, 180.16, 192 centimeters, etc., right? 155. So, I cannot, if there are 100 people in, let's say there are 80 different heights, some of them have same, I can't write 80 different values separately here. I mean, I can, but it's very tedious, it's tiring, it's long. So, what we do instead of that is, we'll take the class like this. Usually we'll start from 100 centimeters height, 100 to 120, 120 to 140, 140 to 160 and so on. How many people's height come under 100 to 120? Measure it. 3, okay 3. 120 to 140, 10. So you are minimizing the data and easy to analyze, right? So we will be dealing with classes in this particular chapter of your 10th grade. As usual, we already know there are three kinds of means that we study, the three kinds of central tendencies is what we call these measures of which we do statistics. There are three central tendencies: mean, median and mode. Mean in common man terms also referred to as average. Median is nothing but the mid value of the data. Mode is nothing but the most occurred value of the data, and we know the relationship between the three tendencies is mode is equal to 3 median minus 2 mean. Mode is equal to 3 median minus 2 mean. We'll make a small rule. For all our classes, we will make them always continuous and solve. While applying the formula of all these classes, we will always make it continuous and solve. Meaning, if I have 0 to 10 and then I have 10 to 20, 20 to 30, 30 to 40, this is continuous data. If I have 0 to 10, 11 to 20, 21 to 30, 31 to 40, class group is group data, it has classes. It's classified, but it's not continuous. So in such cases, we make it continuous. How? Between 10 and 11, the difference is 1. 1 divided by 2, 1.5. So add 0.5 here, subtract 0.5 here. Add 0.5 here, subtract 0.5 here. So you make the data continuous like this. I hope it's understood. With 0, it doesn't matter. 0 minus 0.5 minus 0.5. No one's height is minus 0.5. So we can leave it. So I hope you understood how to make our classes continuous. And this is what we will always keep it. We'll use our formulas with respect to continuous class data. Some few important terms that we need to understand this chapter better. Class limits. So if I have classes like these, class limits are nothing but the starting and the ending value of the class. So 0 and 9 are the class limits of this class. 10 and 19 are the class limits of the class. Class mark. Why do we need class mark first of all? Now if I want to represent a class, 10 to 19 has so many values in between. So a good way to represent it would be a central value, right? To tell that, okay, you know, maximum of the frequency is all about the center. 10 plus 19 by 2, 10 plus 19 is 29. 29 by 2 is 14.5. So you can say, let's say the frequency value here was 10. So then you can say 10, the frequency, or 13 or 25. This frequency lies around 14.5, meaning maximum number of people. So this is just like a representation of a class. So we take this to be xi. Class mark is given as the central value, the center value of the class, that is nothing but upper limit plus lower limit by 2. Class size or interval. Class size or interval. See, 0 to 9, 10 to 19, 20 to 29. How many such numbers are possible between 0 to 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 such numbers are possible. 10 to 19, 10, 11, 12, 13, 14, 15, 16, 17, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Again 10 numbers. So you cannot say upper limit minus lower limit. 10 minus 19 minus 10 is what? 19 minus 10 is 9. But you can see there are 10 possible values that can fit in this class. So you have to calculate class size. You can, if to either count and do it like how I did, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 10 numbers. So put the value of 10, or best method, difference between two consecutive upper or lower limits. 19 minus 9, how much? 10. 29 minus 19, 10. 10 minus 0, 10. But should I do this? Please avoid the 0 case, because many times with 0 you may not get the exact answer. So other than 0, do upper limit and 2 upper limits or 2 lower limits with anything. 30 minus 20, 10. Is it the same thing for continuous class? Here it was not continuous, right? This continuous data, is it the same thing? Yes, it is. 20 minus 10, 10. 30 minus 10, 10. 40 minus 10, 30, 10. 20 minus 10, 10. Ma'am, here I am also getting upper limit minus lower. 20 minus 10. Yes, for continuous data you can even do upper limit minus lower limit. You still get the answer, but you have to take class size like this itself, right? Okay, so now in this class what I also want you to observe is, suppose I tell you make the frequency of that. We have different values, 10, 20, 21, 11, 32, and then we have 8, 6, 13. How many numbers lie between 0 and 10? 6, 8, 1, 2, 3. Correct? So should I write 3 here? No. Should I include this 10 in the first class or the second class? If it is continuous data, then you should not include the upper limit value. 10 will belong to the second class. So 8 and 6 goes to first class. 10 and 20. 10 to 20. Does 20 come in the second class? No, because then this is upper limit. 20 will belong to next. So you have to start from lower limit and avoid the uppermost limit when it is continuous set. Remember that. So 10 to 20, who all lie? 10, 11, 13, 3. 20 to 30, 20 lies, 21 lies, 2. And 32 belongs to the last case. Understood? So we learned two things here. If you want to calculate the class size, we go for 2 consecutive limits, subtraction of 2 consecutive upper limits or 2 consecutive lower limits. And same thing here as well. And the other thing that we also learned was, if it is a continuous data and you have to calculate frequency, please include the value where the lower limit is. 20 is not included in this class but is included in the third class. So now we'll see how to find mean and what are the different techniques. The first technique we learned is direct method. When we look at the data of in the question, class will be given and frequency will be given. Class and frequency will be given in the question. So for direct method, the formula is given as x bar is equal to summation fi xi by summation f. So we have, what will be our columns? We have class. From class I can find xi, which is my class mark. Find xi. Fi is given in the question, frequency. From this I can therefore now find fi into xi. I have class, find xi, fi is given in the question, multiply these two and find fi into xi. So this finally gives us our table. For the formula, what all do we need? We need summation fi xi. So find summation fi xi. We need summation f. So find summation fi over here. Once you find these, simply substitute summation fi xi, substitute summation f, you get your mean value. Mean is represented by x bar. What does this I represents? Xi, X1, class mark of first class, X2, class mark of second class. So this I is nothing but 1, 2, 3, how many of classes you have. Similarly, F1, frequency of first class, F2, frequency of second class, F3, frequency of third class. That's what the I refers to. So usually in summation we write like this. Let us say we have 5 classes, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Then we represent this as I as starts from 1 and goes to 5. That's why we write that I. You can ignore this. That's what the I means. That's what you have to write in a summation completely. But you can ignore it and write this much. It is fine. We next come to assumed mean method, in which the formula is given as the mean x bar is a plus summation fi di by summation f. Let us see how we get all these values. A is referred to as the assumed mean. How do we do that? So here, as usual, class will be given in the question. After class, you have frequency, but we want class mark. So first we will write class mark while writing the table in our books. After that, we will put the frequency whatever is given in the question. Now you can assume the mean. How do I assume the mean is the next question here now. So in this assumed mean technique, we assume the mean as any of the central values. Okay, so count if there are 5 classes, 1, 2, 3, 4, 5, go to the third class, center class, and select the mean. That will be your assumed mean, middlemost xi. Suppose there are 6 classes, you can select 1, 2, 3, 4. So third class or fourth class, anybody's xi value, no problem. So what is a assumed mean? How did you assume that mean? Middlemost xi value. Middlemost xi value. That will be taken as the assumed mean. Circle it in your table and mark A. Frequency is already given the question. Now we have di. What is that di? Di is nothing but the deviation factor. It is given as xi minus A. Class mark minus your A. That is your di. Xi minus A. Now once you find your di, what's next? Fi into di. So if it was a previous problem, previous technique, you have only 4 columns. Now we've introduced 5 columns here. So Fi into di. This will give. Now you already have A, summation Fi di, summation Fi. Substitute A, summation Fi di and summation Fi, you will get your mean. When doing problems with the assumed mean method, you will observe that the di here changes with a common factor, meaning if it's it will be few negative values also might be there. If it's going from minus 30 to minus 20, minus 20 to minus 10 to 0, 10, 20, 30. So it is increasing with a common factor. So such common factors, when you observe, if they have common factor, you can also go in for the third technique, standard deviation technique. Standard deviation, the deviation is constant, it's standard, the deviation is increasing at constant rate, it is standard. When is it usually standard? When your classes are regular. What are these regular classes, irregular classes? If I say 0 to 10, 10 to 20, 20 to 30, 30 to 40, regular. If I simply say 0 to 10, 10 to 16, 16 to 20, 20 to 40, irregular. Can you see the class sizes are irregular? They are changing at different rates. Class size, the difference between them is different. So the heights of these classes, the class sizes are different. They are irregular classes. These are regular classes. So for regular classes, D is usually standard, same, constant, increasing with the same factor. So when D is constant, we can go in for the next technique called standard deviation method. Done for regular class data, and you can see in your data also while solving, Di should have a common factor. It should increase with a common factor. If it's different, you cannot apply standard deviation. How do we do this? The formula is given as x bar is equal to a plus summation fi ui by summation fi into h. So what will our table look like for this? As usual, you have your class. After class we need xi. Fi is given in the question. If it was direct method, you would write fi xi. If it was assuming method, you would write di and then fi di, correct? So here you will write ui. Ui is given as xi minus a by h. So once you find ui, you have fi ui. That's all. How did we get that a? Once you write class xi fi, you can assume your mean. How do you assume your mean? Middlemost xi value, just like how we did in the previous case. So we have a, you have ui, this thing. So summation fi ui, summation fi, h is nothing but the class size. If it's regular, you can have a class size. If it's irregular, your class size is varying, then you can't apply this formula. So can you apply assuming method for irregular class data? Yes. If the class size is varying over there, you can still apply the other two methods. But can you apply standard deviation? No, it goes in the name, standard deviation. Deviation should have a common factor. So if you know how we have summarized these formulas and this table and you've understood how to draw the table, very easy. We can just start off with problems. Ma'am, how do we know whether to apply the first method, direct method, or assuming method, or standard deviation method? If your classes and frequency are very small, like your classes are between 0 to 20 and your frequencies are usually in single digits, then please go for the first method, direct method. If your classes are a little bigger, between 20 to 40, 20 to 50, and your height is also small, that means the class size is small, h value is small, then go for assumed mean method. If the class is big, xi is big, or fi is big, or both are big, then go for the last technique, standard deviation technique. But point to be noted, if you want to use standard deviation technique, the classes have to be regularly sized. It cannot be irregular. H has to be constant for every class. If it's not mentioned in a question, follow this. Sometimes you may not be able to recognize whether I should use assumed mean or standard deviation. No problem, it's interchangeable. You will get the same correct answer what everyone else is only getting. No change, nothing to worry over there. Approximately same answer all of us will get. So in the question, usually they tell you which technique to use. Solve this, find the mean by using an appropriate method, you will have to decide. If they say find the mean by using direct mean method, please use direct mean. If they say find the mean using standard deviation, use standard deviation only. If the data is small or big or whatever, if they mention the method in the question, you have to follow it. If they don't mention, is when you have to decide which method you have to use. Let us begin with exercise 14.1, first question. A survey was conducted by a group of students as part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. Usually the total number of observers or the total frequency is given in the question. This 20 houses, if you count the number of houses here, how many houses did they see? 20. See, 1 plus 2 plus 1, 4, plus 5, 9, 9 plus 6, 15, 15 plus 2, 17, 17 plus 3, 20. So you can observe, usually summation f is given in the question, not always, but usually. Find the mean number of plants per house. Which method did you use for finding the mean and why? As you can see, in this kind of data, the numbers are small. Xi, the classes are also small, up to 20. And the frequencies are also small. I can go in for the first technique, the direct mean method. So how do we do it? Classes are given in the question, frequency is given in the question. So start forming your table. What will be the first column? Number of plants. Put number of plants as the first column. Then you have Xi as the class mark, second column. Frequency is nothing but number of houses, which is nothing but Fi. Please write like this. Then what's your fourth column? Fi into xi. Pause the video and find these values. I will directly be putting up the table. Pause the video, find these values. After you finish it, verify it with the table I have put up. So check the table. Number of plants was given. How did you find the class mark? You just added 0 plus 2 by 2. Lower limit plus upper limit by 2. We already learned the definition of class mark and we know how to find it. 2 to 4, 2 plus 4 by 2, 6 by 2, 3. 4 and 4 to 6, 4 plus 6, 10, 10 by 2, 5. 6 plus 8, 14, 14 by 2, 7. 8 plus 10, 18, 18 plus 18 by 2, 9. 10 plus 12, 22, 22 by 2, 11. 12 to 14, so 12 plus 14, 26, 26 by 2, 13. Fi was given in the question. If you add and see, you get 20 here, which is nothing but what was mentioned in the question. Fi into xi, multiply it and then you add it. So now what happens? Now we apply the direct mean formula. X bar, the mean is given as summation fi xi by summation f. So 162 by 20. If you solve this, you will find it to be 8.1. Is there any units for mean? Yes, there is a units for mean. The units of mean, median, mode, anything, any of the central tendencies is nothing but the unit of the class. Please put a note, the unit of any of the central tendencies, that is mean, median or mode, is same as the unit of the class. What is the unit of the class here? Number of plants. So 8.1 plants. Question 2. Consider the following distribution of daily wages of 50 workers of a factory. What is this number 50? Summation F. So they have given daily wages and number of workers. If you add 12 plus 14 plus 8 plus 6 plus 10, you will see it as 50. Find the mean of the daily wages of the workers of the factory by using an appropriate method. Now, which method will you use among the three methods we have? You can see the class is big, 500 to 520, meaning xi value is big. 500 plus 520 by 2 is 510. So I have to go for assumed mean method or standard deviation method. Standard deviation method is good when your classes are very big and there's a regular height, right? Regular size of the classes. Here you can see this class size is regular, it has 20, 20, 20. So it is recommended that we go for standard deviation. If nothing is mentioned in the question and if you are confused whether should I do assumed mean method or should I do standard deviation, if you are confused, please choose standard deviation. Any which way, whichever method you use, you will approximately get the same answer. So we will be going for standard deviation method in this case. How do we do standard deviation method? For standard deviation method, we have to first write class, then what's the next one? Xi, then Fi. Next, before you do UI, you have to choose your A, assumed mean. How will we choose our assumed mean here? 500 to 520. So you find the xi to be 510, 520, you find xi. You will see assumed mean will be there are 1, 2, 3, 4, 5 classes. So the centermost class, the middlemost value, the middlemost xi value, that's nothing but 540 plus 560 by 2. So choose your A. After we choose your A, what will be the value of A? You first form your table, choose your centermost value of A, then substitute ui is equal to xi minus A by h and then find Fi into ui. Pause the video, solve this and then verify if you get the same answer as what's put up over here. So you have your first column daily wages, you found your xi's. We chose the middlemost xi value. So 1, 2, 3, 4, 5, middlemost is 550. So we choose 550 as our xi value. Then add, put the frequency column, after which find ui. So ui formula was xi minus A by h. Who's the A here? 550. Xi minus 550 by h. So substitute xi 510 minus 550 minus 40 divided by h. What is the value of h here? We told you to find h, you have to subtract 2 consecutive upper limits or 2 consecutive lower limits. 540 minus 520, 20. So h value is 20. So what happens to the first one? 510 minus 550 is minus 40. Minus 40 by 20, minus 2. Similarly, find the other ui's. Then multiply fi into ui and you get this column. Now for the formula of the mean, x bar is given as a plus summation fi ui divided by summation f into h. So I need summation fi ui, we found out minus 12. I need summation fi 50. Now we substitute this. What is the assumed mean? 550 plus summation fi ui minus 12 summation f 50 h 20. Solve this to get the value of the mean. 550 plus 0 and 0 cancels, 12 twos are 24 minus 24 by 5. 550 minus, if you solve 24 by 5 you will see it's 4.8. 550 minus 4.8, 545.2. Is there any unit? Yes, there is a unit, the same unit as the class. So this is 545.2 rupees. The mean of the data is rupees 545.2. So the mean of the data is 545.2. Question 3. The following distribution shows the daily pocket allowance of children of a locality. The mean pocket allowance is rupees 18. They have given you the value of x bar over here. You have to find the missing frequency. See, the frequency values are not very small. It's not all single digit. There are double digits also. Plus, if you look at this, the classes, they are not single digits, but they are small but not very small. Also, h is not large. The size of the class is only 222. So instead of using standard deviation here, we can use assumed mean since nothing's mentioned. We will stick to assumed mean method in this question. Why? Because it's not very small, it's not too large the data, and second, the h is small, size of the class is small. So using assumed mean, let us first make a table and then we'll see how we find the value of f. So to use the assumed mean method, what's the step? First write your class, find xi and find fi. Next, choose your assumed mean. Assumed mean is the middlemost xi value. So we have 7 here, middlemost will be this fourth one. So a is equal to 18. We chose our assumed mean. Next you have to find the deviation factor. Di is equal to xi minus a chosen over here is 18, so xi minus 18. 12 minus 18 minus 6, 14 minus 18 minus 4 and so on. Next fi into di, multiply fi into di. For the formula of assumed mean, x bar is equal to a plus summation fi di by summation f. So you need summation of fi di and summation of f. So we found summation of fi di and summation of f. Now how do you find the summation of f? 7 plus 6 plus 9 plus 13. So 7 plus 6, 13. 13 plus 9. How much is 13 plus 9? 22. 22 plus 13. 35. Leave the f. 35 plus 5. 40. 40 plus 4. 44. There's another f. Add it. That is like saying what is 7 plus 5 plus x? 12 plus x, right? You leave the x as it is. Just like that, we don't know the f, leave the f as it is. Similarly, fi di, add all the constants and leave the 2f as it is. So if you add everything, you'll get minus 40. So it's 2f minus 40. Let's now substitute. A is 18 plus fi di 2f minus 40 division by summation f, which is 44 plus f. X bar is given in the question as 18. So now you have to solve. 18 cancels. 0 is equal to 2f minus 40 by 44 plus f. 44 plus f will get multiplied with 0 and become 0. So 2f minus 40 is equal to 0. Send the 40 this side. 40 is equal to 2f. 40 by 2 is equal to f, and the f value is therefore 20. Does frequency have a unit? No, because here we are talking about the number of children. So it is 20 children. Okay, or the f value is 20. Question 4. 30 women were examined in a hospital by a doctor, and the number of heartbeats per minute were recorded and summarized as follows. So number of heartbeats per minute was here. How many women have 65 to 68 heartbeat? 2 people. 71 to 74, 3 people. Find the mean heartbeats per minute for these women, choosing a suitable method. Which method will we go in for? You can go in for again assumed mean method or standard deviation method if nothing's mentioned. So nothing's mentioned. I am choosing standard deviation because the xi values are large. So start off, standard deviation, what all do we need? We need xi, fi, correct? After xi, fi, you need the value of assumed mean. Who will be assumed mean here? There is 1, 2, 3, 4, 5, 6, 7. So middlemost, choose the xi of that class. Start making your table, pause the video, make your table and recheck your table with mine. So we have the classes here. We find class mark by doing upper limit plus lower limit by 2. We chose the assumed mean from 74 to 77. The assumed mean middlemost xi value 75.5. We have the fi given in the question. Ui is xi minus a by h. Xi minus a. A chosen here is 75.5. So 75.5 and h value is consecutive upper limits or lower limits. Subtract, you will get the value of h. So 71 minus 68. How much is 71 minus 68? 3. So the h value is 3. So assume mean is 75.5 and h value is 3. Substitute here xi minus a by 3. So it should be xi minus 75.5 minus 75.5 by 3. Subtract all this, you will get ui, then fi into ui. Now put the formula, x bar is equal to a plus summation fi ui by summation f into h. A is 75.5 plus summation fi ui 4, frequency 30, h 3. So 3 ones are 3 tens are. 4 by 10 is 0.4. So 75.5 plus 0.4. 75.9 heartbeats per minute is the mean of the data. Question 5. In a retail market, fruit vendors were selling mangoes kept in packing boxes. These boxes contained varying number of mangoes. The following was the distribution of mangoes according to the number of boxes. So how many boxes? There were so many boxes in the fruit market. Each box did not have an exact number of mangoes. It had 50 to anything varying 50 to 64 we had. So how many boxes had 50 to 52 mangoes? 15 boxes. How many boxes had 59 to 61 mangoes? 115 boxes, something like that. So find the mean number of mangoes kept in a packaging box. What method of finding the mean did you choose? So what will you do here? As you can see, the fi values are large, 110, 135, 115, and so definitely no direct mean, direct method, so you can go in for assumed or standard deviation. When nothing is mentioned, preferred method is standard deviation. So we will stick to standard deviation because also xi is more than 50, easier to calculate. So all of you go in for the standard deviation method, draw the table and pause the video, draw the table, verify it with mine. So we have number of mangoes. After the class you have class mark, choose the and then fi, then you choose the assumed mean. Assumed mean is middlemost xi value. There are 5 here, so centermost is the third one. A is equal to 57. Ui is given as xi minus a by h. A we saw assumed mean is 57. What is h? Any two consecutive limits, subtract 59 minus 56, 3. So h over here is 3. Substitute xi minus 57 by 3, find these values, then multiply fi into ui, you get this. For the standard deviation formula, you need summation fi ui, find summation fi ui, you need summation f, find summation f. So we therefore now apply it to the formula. X bar is equal to a plus summation fi ui by summation f into h. A, what is the a? 57 plus summation fi ui. What was the summation fi ui? 25 by 400 h 3. Solve this. 25 by 400. 25 ones are 25. 25 16s are 400. You can check. Yes, it's 25 16s are 400. So now 3 by 16. So 3 by 16. 16 zeros are, so 16 now, 1s are 16, 40 remaining. So now what happens? 16 watts of 140, you can say 16 10s are, 16 8s are, 16 7s are. 16 8s are would be a good number, 8 6s are 48, 8 1s are 8, 8 plus 4, 12. So 0.14 up to 2 decimals is enough. So 57 plus 0.14, which is giving us 57.14 mangoes, is the mean of the given data. Question 6. The table below shows the daily expenditure of food of 25 households in a locality. What is that 25? Summation f. You have daily expenditure, you have number of households. Find the mean daily expenditure on food by a suitable method. As you can see, the classes are large values, big values. That means xi is going to be big. So we will go for standard deviation method. Going for standard deviation method, we have class, find xi, find fi, choose your assumed mean. After you choose your assumed mean, substitute ui is equal to xi minus a by h. And then what do we do? Find fi ui. Come on, do it. Pause the video, do it, and then verify if your table matches mine. So you can see we have class, we have the xi, we have the fi. Choose your assumed mean, middlemost xi value. Middlemost xi value, there are 5 here, so middlemost is 225, that's the third one. So u is equal to xi minus a by h. A we found the assumed mean to be 225, and what was the h value? Subtract any two upper limits or lower limits. 250 minus 200 is 50, so I took it as 50 here. Now substitute and find the answer. Let's begin. A is 225 plus minus 7 summation f 25 h 50. 1s are 2s are. 225 minus 14. 225 minus 10, 215. 215 minus 4, 211. What is the unit of this mean? The unit is nothing but the same unit as the class. The unit of the class is in rupees, so this will also be in rupees. Rupees 211 is the mean of the given data. Question 7. To find out the concentration of SO2 in the air in parts per million, that is ppm. What is this ppm? It's nothing but a unit of concentration, right? So like how you have unit of mass is kg, etc. ppm, like how you have liters, meter cube, like that ppm is just a unit. The data was collected for 30 localities, that's the summation f, in a certain city and is presented below. So concentration is given, frequency is given. Find the mean concentration of SO2 in the air. Oh ma'am, this is such a small value, you know, we can go in for direct mean. No, again, this is looking like it's very small over here, but it's in 0.00. So when you have too many decimals, if I divide point something something divided by point something something, it's easy to remove the decimal, right? So the h will also be 0.04. See, 0.12 minus 0.08, 0.04. So when you divide like that, it's possible to remove the decimal. Standard deviation is best. I'm telling you again and again, if nothing's mentioned, to be on the safest side, do standard deviation for the most accurate answer, and most, because that is also lengthy, it will carry heavy marks. Okay, so use standard deviation, solve it. There are 5 classes, so your middlemost xi value will belong to this class. Solve it, pause the video, verify your answer with my table. So write the class, write the xi value, write the frequency. Now choose your assumed mean. How will you choose the assumed mean? There are 6 classes here. So your assumed mean can be the middlemost xi value. There are 2 middlemost xi values, third one and the fourth one. You can choose any one. Most of the books choose the upper one, so I will choose the third one. So when you have even number, you have 2 xi values, you choose any, you'll still get the same answer, but we will be choosing the higher value. I mean the upper one. Okay. So pause the video, make the table, verify it with mine. So you have your class, you found the class mark, how upper limit plus lower limit by 2, 0.00 plus 0.04 by 2, etc. Do it like that. Then you have frequency. So choose your assumed mean. We chose the assumed mean to be, you can choose 0.10 or 0.14. We've chosen 0.10 here. Most books take it that way itself. So if you have 2 assumed means that you have a choice, take the low one, meaning the upper one. So u is equal to xi minus a by h. What is h? H is subtraction of 2 consecutive upper limits or lower limits. 0.12, 0.12 minus 0.08, 0.04. So ui becomes xi minus a, which is 0.10, divided by h, which is 0.04, like we saw. Divide it, you will see you get these ui values. This is almost the end of your textbook, so you should know how to do faster mathematics at division, multiplication, plus you're in 10th grade. So now fi into ui, fi into ui, multiply it, you get fi into ui. So we have summation fi ui as -1, summation f as 30, substitute and find the answer. X bar is equal to a plus summation fi ui by summation f into h. What is a? Assume mean 0.10 plus summation fi ui -1, summation f 30, h 0.04. 0.10 plus into minus minus 0.04 by 30. 0.10 minus, if I multiply this further, what happens? Multiply and divide with 100. So it becomes 4 by 30 into 100. Just do 4 by 3. Okay, keep all the zeros as it is. So 4 by 3. 4 by 3. 3 ones are 3, remainder 1. 0.000. Bring down a 0. So 3 3s are 9. Bring down a 0. 3 3s are 9. So this becomes 0.10 minus 1.3. There are 3 zeros here, divided by 1000. 0.10 minus division by 1000. So decimal moves to the left. 0.0013. 0.10 minus 0.0013. How do we do it? Put the zeros here. Cancel 9, 9, 10. 10 minus 3, 7. 9 minus 1, 8. 9 minus 0, 9. 0, 0. So your concentration is 0.0987 ppm. Same unit as the class. Question 8. A class teacher has the following absentee record of 40 students of a class for the whole term. Find the mean number of days a student was absent. So in this particular question, again the numbers are more than 20. You will feel like using assumed mean or standard deviation. Yes, so you will go for assumed mean or standard deviation. Now if I want to use standard deviation, since nothing is mentioned and I want to be safe, I'll try to use standard deviation, but wrong. Why is it wrong? Observe carefully, your class sizes are irregular. 0 to 6, 6, 6 to 10, 4, 10 to 14, 4, 14 to 20, 6, 20 to 28, 8, 28 to 38, 10, 38 to 40, 2. Class sizes are irregular. You cannot use standard deviation method. So you have to use assumed mean method only in this question. How do we do assumed mean method? First draw the class, then find the xi. How many, after xi, put the frequency, then choose your assumed mean. 1, 2, 3, 4, 5, 6, 7. Middlemost value 1, 2, 3, 4. So in the middlemost class, that one's the xi. Choose the xi, then find di, then fi into di. Pause the video, draw the table, match it with mine. So after you find xi, here we chose a to be 17. Now when you do di equals xi minus 17, you will get this. Please observe the di's are not, they don't have a common factor. 14 to 9 is plus 5, 9 to 4 is plus 4, 5 to 0 is plus 5, 0 to 7 is plus 7, 7 to 16 is plus 9, 16 to 22 is plus 6. You can see it does not have a common factor, which is why in standard deviation we said if you want to apply standard deviation, then the di should be standard, meaning common factor should be there. So you better use assumed mean method over here. Then find fi into di and now substitute. X bar is equal to, what is the formula? A plus summation fi di by summation f. A, what is the A? 17 plus minus 181 by 40. 17, on solving this you will get minus 4.52. Now on solving this you will get 12.48. Does it have a unit? What is the unit of the class here? Number of days. So that means approximately 12.48 days were the number of days a student used to miss class. That's the mean. Question 9. The following table gives the literacy rate in percentage of 35 cities. What is that 35? Summation f. Find the mean literacy rate. Again, these values are more than 50 and again frequencies are double digit. Better to use assume mean or standard deviation. So again, if you have to choose, please choose standard deviation. We choose standard deviation over here. You can see the class size is also regular 10, 10, 10, 10, 10. So standard deviation is a good option. Come on, pause the video, make the table, verify it with mine. So after you find xi and put the fi, assume mean is the middlemost xi value, so 70 ui. Ui is equal to xi minus a by h. A we already chose 70. What is h? Subtract any two consecutive upper limits or lower limits. 75 minus 65, 10. So h value here is 10. So ui becomes xi minus 70 by 10, which is nothing but this. Substitute in this and you find the values of ui. Then find fi into ui. You will see that is summation of fi ui is minus 2. Substitute x bar is equal to a plus summation fi ui by summation f into h. Now what is the a? 70. Summation fi ui minus 2. Summation f 35. H 10. Solve this. 5 2s are 5 7s are. So minus 4 by 7. 70 minus 4 by 7. 7 zeros are 0. Bring down one more 0. 7 5s are 35. Bring down the next 0. 7 what's are? 7 7s are 49. 0.57. So this becomes 69.43. What's the unit? Unit of class over here was in percentage. So this will be 69.43 percentage.